Hello, I welcome you all. The problem reads that the small washer is sliding down the chord OA when it is at the midpoint. Its speed is 28 meters per second and this acceleration is 7 meters per second squared. Determine the velocity and the acceleration of the washer at this point in terms of cylindrical coordinates. This problem is coming from the Engineering Mechanics Dynamics 14th edition by R.C. Hibbeler. So in this particular problem, we are not experiencing any curvilinear motion. Here we have rectilinear, right? This is just a straight line from A to O. And now we are being asked to express the velocity and acceleration of the washer in terms of its cylindrical coordinates. Right, so let's write down this. Let me make sure to say theta itself. Let me draw this. So we do have here our R, right? So we have theta here. Let's say this is our theta here, and this theta we know is constant, it's not changing. This is theta, this is R. Okay, so let's write something and say because theta is constant, theta dot is equal to 0 and theta double dot. Okay, therefore the transverse component the transverse components, okay, of both V and acceleration will be 0. So let's write down the equation. So writing this as a vector, we have VR, UR like so, plus V theta, U theta, and then we have VZ, UZ. Alright, like so, and we know that our VR, our VR is just equal to R dot is equal to R dot, and our VR, our V theta is equal to R theta dot, and our VZ is equal to Z dot. Okay, great. And of course this part is equal to 0. And then we have acceleration. Our acceleration as a vector, this is equal to AR, UR like so, plus A theta, U theta like so, plus AZ, UZ like so. And our AR is just equal to R double dot minus R theta dot squared, R theta equal to R theta double dot plus 2 R theta dot, and then AZ Z double dot. But we know that this part is 0, this part is 0, as well as this part there. Okay, because theta is constant, therefore we expect everything with theta dot and theta double dot to be equal to 0. Right. So let's work it out. So what we need to do is to find the unit vector along OS so that we convert these scalar quantities of velocity and acceleration into vectors. So let's find the unit vector AO. Okay. So we say unit vector AO, which is just equal to RAO divided by this magnitude. And this is just going to be equal to, so this coordinate is 2, 3, 6. This one is 2, 3. So this just becomes a minus 2i, minus 3i, and a minus 6k. Okay. And then magnitude of that, we have 4 plus 9 plus 36 plus 49. Root of that is a 7. Okay. And then we have UR, which is just equal to, let's call this point here B. So this is equal to UOB, and is equal to ROB divided by ROB magnitude. And this is equal to 2i plus 3j, 4 plus 9, that's 13, so root of 13. Okay. The velocity vector as well as acceleration vector, but before we do so, let's write down the magnitude, our v, which is equal to this vector for velocity is equal to 28 meters per second, and our a, which is equal to that, this is equal to 7 meters per second, and therefore our velocity as a vector is going to be equal to v times the unit vector, which is UAO. Right. And our AO, where is it? It is here. And our V, it is so what do we have? We have 28 by minus 2i minus j minus 6. This is divided by 7, 7, 7. And this therefore becomes a minus 8i, a minus 12j, and a minus 24k. And acceleration, there we go, acceleration by UAO. Okay. We have a 7 minus 2 over 7i minus 3 over 7j minus 3 over 7j, and then 6k over 7. Then this just becomes a minus 2i, a minus 3j, and a minus 6k. So let's write down now the scalar values of VR. VR is just going to be equal to, so we are mapping, think of this as mapping. We are mapping this onto this coordinate like so, and also this onto there. Okay, this is what we're doing. So we can use the dot product. Remember the dot product, dot unit vector UR. Okay, and this is just going to be equal to minus 8i minus 12j minus 24k dot what do we have? Our UR, we found our UR, it is minus 2i minus 3j over root of 13 root of 13. When we do the dot, we have our magnitude as minus 8 by That was minus, right? Let me check. Okay, you error, this is positive. Okay, let me write this as 2 root 13 I plus 3 over root 13 j. So this becomes as minus 8 by 2 minus 12 by 3, okay, divided by root of 13. This gives us a minus 14.42 meters per second. And then we do have Vz, and Vz is just the vector itself by the unit vector along that direction, which is just equal to minus 8i minus 12j minus 24k and then dot k. And this just gives us a minus 24 meters per second. Then we have acceleration AR. This is equal to the vector itself dot UR, and this is just equal to minus 2i minus 3j minus 6k dot 2 root 13i, okay, plus 3 root 13j. Therefore, AR is just equal to minus 2 by 2 and minus 3 by 3 divided by root 13. And this we get a minus 6.1 meters per second squared. So minus 6.1 meters per second squared. And then AZ equal to acceleration vector itself, then UZ, this is equal to minus 2i minus 3j minus 6k dot k. And this therefore gives us minus 6 meters per second square. So let's outline the solution. So we have, you can represent these if you want to as vectors. We already have all the information. So we have our VRR, we have our VZ, okay. We have our AR, and we have our our AZ. Right. So I think this is about it, and I hope this video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and see you in my next screencast.